Good morning, Prof. Norita.
Good morning. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. I'm sorry, Pak Aan, there are still emergency meeting in the Dean, so I will help this morning for study this morning, Prof. Norita.
Yes, can.
Assalamualaikum, Prof. Norita.
Ya, waalaikumsalam.
Ya, Pak Aziz, saya minta tolong di handle ya.
Aha, boleh.
Posisinya sekarang masih rapat soalnya ini belum selesai. The session will be held by Mr. Nur Aziz Salim, Prof.
Insyaallah, boleh. Terima kasih.
I have meeting already, so
Okay.
I need Prof. Nur Aziz for this session. Thank you.
Insyaallah, thank you.
Prof. Norita, it will be start now or at 9 o'clock, Prof. Norita?
I am okay whichever. If most of the students are already in, we can begin. I am okay. If we want to begin it now, I am fine, inshallah. We are expecting like how many total students, yeah? Dr. Aziz?
Yeah, Prof. Norita, student is already joined since 30 o'clock, so I think now it's okay to starting, Prof. Norita.
Okay, thank you.
Yeah.
Okay, I will begin now. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and good morning, everyone. Okay, inshallah, today we will go, this is our third class, our third lecture on electronics, which we will actually see what is diode, thyristor, and all about. However, as usual, before we proceed with all that, I will go with a recap, and all of you are requested to actually go for a short pop quiz, yeah, which is multiple choice. Okay, so but before we go for pop quiz, allow me to recap what we have actually learned last week. 1 minute, yeah, I share the slide. Okay, so this is today. Okay, like last week, if I have more students last week, this week I have less than 100. Okay, so for low pass filter, we have learned 3 types of filter, which is low pass filter, high pass filter, and band pass filter. Yeah. So low pass filter, as we know, it will actually allow, okay, from 0 to whatever the cutoff that we are going to set as our bandwidth, yeah, as the cutoff and our bandwidth. And this is the circuit that actually can perform as a low pass filter that will limit whatever bandwidth that we have set. So how are we going to limit the bandwidth? Yeah, this particular bandwidth that we are going to allow, the cutoff we call it. Okay, so this is actually the equation that we use to compute what is the value of C and the total impedance. Yeah, so all 3 filters actually utilize the same equation, but you need to know how the suitable value of C and R for it to perform as filter. Well, before I go to band pass filter, I will go to high pass filter first. Okay, we have seen, we have actually recapped what is low pass filter. So for high pass filter is actually a filter that will allow higher frequency and reject certain lower frequencies that we have actually set to it. And the use of high pass filter normally is to reduce harm and noise, yeah, in audio. Okay, and again we are using the same frequency here. If you see here, it's going to be the same frequency, and this is actually the response, the frequency response of a high pass filter and the circuit of it. Yeah. Okay. Then I will go to A band pass filter. Okay, we have seen what is low pass filter: allow, cut off, high pass filter, cut and allow. So a band pass filter is comprised of a high pass filter and a low pass filter to produce something like this. Okay, which it will allow certain frequency and it will cut off certain frequency. It's a combination of low pass filter and high pass filter for us to get the band pass filter. Okay, so I have recap, and now I'm going to give you 20 minutes, yeah, for you to do your pop quiz. I will share the link with you for the quiz. You know why I insist that we go for pop quiz, and it's multiple choice. It's not, you know, it's not what shall I say? It's not subjective. Just to actually, if you manage to answer this, which means the basic concept of filters, the 3 types of filters, you have understood actually. Okay, 1 minute. I will try to get. I'll stop share first. Where's the chat? Okay, I have put the link at the chat box. You may begin now. I will set my alarm. 20 minutes, yeah? It's very easy. I mean, those who can understand, you can finish less than 20 minutes. 10 questions, answer all. You may begin now. I set my alarm. Okay, 1 submitted. Please try everyone to answer. If you don't try, you wouldn't know whether you understand what we have actually went through last week on filters, yeah? Because last week, I have only like 60 of you responded to the pop quiz. Okay? Because this is the way that we know whether we understood or not. Because at the end, when you submit, you will know what is your marks. Yeah. So once you know what is your marks, we can check ourselves. What is it that we understand and what is it that we need to actually study and understand more. Okay, many have submitted, around 19 of you. One got full mark, very good. Matthias Octa Roy Hans, you got full mark. Congratulations. For those still answering, you have another like 10 minutes. Okay, one more full mark. Bayu Adi Pambudi. Congratulations. Okay, 54 responded. And we have another 1 minute. We have another 5 minutes. Lagi 5 minit ya anak-anak. Oh, you want the link? Okay, okay. Your. Sorry, I did not see your message. Okay, 79 responded, very good. And we have my students, all is 104. And you have another 3 minutes, okay? And after that, I will close for response. As of now, we have several that can get full marks, which is very good, okay? Which means you understand the basic concept. Okay, 94 settle. 94. We have a few more. Please finalize before I deactivate the which means you could not respond after that. Very good this time. Okay, time stop. Thank you, everyone. Okay. I will deactivate now. Yeah, so in all, I have 101 responded. Okay, so I have not accepting responses anymore. Thank you. Okay, we are done with that. Thank you. Very good. I'll pass the marks to your professor later on, yeah? Okay, so today we will start with our lecture, which is on Shockley diode. Then we will see what is diode, triode, and so on. Okay, I'll share my slides now. Okay, so the first one that we're going to see today is, I'm trying to actually put this up. Okay. Shockley diode. So what is Shockley diode is all about? Yeah. This is actually a device, yeah, which is formed based on 4-layer diode, PN, P and N. Okay, I guess all of you have actually went through what is PN, PNP, NPN during your transistor, yeah. Okay, and the name Shockley actually is based on the inventor's name, which is William Shockley. So we will see what is actually the specialty of Shockley diode. Is actually like a sandwich, yeah, which is being sandwiched between the P and the N, and in between we have N and P. It's being rotated that way, yeah. The arrangement. So how it is the physical diagram, it looks like this, where the P and the N is the extreme, the P is for the anode and the N is for the cathode, while the N is connected as such. So this is the equivalent schematic, and this is the schematic symbol of our Shockley diode. Okay, so recall that. Okay, this is actually the equivalent schematic. This is the schematic diagram. So if we don't have any voltage being applied here, there will be no current. That's logic, yeah. So as the voltage is initially increased, okay, I will actually explain to you how will actually this Shockley diode to be on and off. Okay, so how a Shockley diode ever conduct current? Yeah, so an ideal bipolar transistor, yeah, will never conduct collector current. Remember, we have collector, base, and emitter. Yeah. For each transistor, there are 3 things that you need to know, which is the IC, IB, and IE. Okay, collector, base, and emitter, and the currents associated with each stage. Yeah. So an ideal bipolar transistor, it will actually never conduct collector current if no base current flow. It starts from the base. Okay, I'll just off my WhatsApp. It's disturbing. Okay, gone. Okay, we continue. Okay, so so real transistor, okay, real transistor, no matter how much or how little the voltage we apply between the collector and emitter. Okay, base is always in the middle. We have collector and emitter. Emitter that is emit the currents. Yeah. Okay. So real transistor, on the other hand, they have actually defined the limits to how much collector emitter voltage of each can stand before it arrives at the breakdown. Remember, we have the threshold voltage, yeah, and that depends on the type of transistor, whether it's silicon or germanium, yeah. But normally we will use silicon. That's the normal one. Okay, V threshold is around 0.7. Sorry. So if 2 transistors are connected, like we have seen here, yeah, here. Okay, it's like 2 transistors connected, yeah. What happened actually, it forms a Shockley diode, yeah, and each one will conduct if sufficient voltage is applied by the battery between the anode and the cathode, yeah, to cause one of them to enter the breakdown and further activate. So once one transistor breakdowns and begin to conduct, it will actually allow, okay, it will actually allow the base current, yeah. Remember, this is the base, yeah. This base is connected to the collector of the next one, and the collector of the first transistor is connected to the base of the second transistor. Okay, because this is PNP and this is NPN. So what happened? Once one transistor breaks down and begin to conduct, yeah, it will allow the base current, okay, it will allow the base current through the other transistor that will further cause it to turn on in a normal fashion, okay, normal at normal as a normal transistor, which then allows the base current, okay, the base current through the first transistor. So at the end, what happened is actually both transistor, okay, will be saturated, which keeps each other on instead of off. Okay. Okay, a Shockley diode. Okay, what we are looking here is actually a Shockley diode. Yeah. Okay. Here. Okay. Where? Okay, two transistor here. Yeah. Two transistor which is connected to form a Shockley diode. Okay. So a Shockley diode can be forced to turn on. Okay, by applying a sufficient voltage between the anode and the cathode. Here, between the anode and the cathode, which will cause one of the transistor to turn on, yeah, which then turns the other transistor. Then this is what we call it latching, okay, where both transistor on where each will tend to remain. So now the question is, how do we know, or how do we now get the two transistor to turn off again? Macam mana? So once it is on, how do we turn off again? So even if the applied voltage is reduced to a point below, okay, the Shockley diode conducting, it will remain conducting because both transistor now base current dia macam, you know, they feed one another, maintain regularly, which that control the conduction. So how can we off it? So this is done by reducing the applied voltage to a much lower point where it will cause too little current flows to maintain the transistor bias. Ingat transistor kalau dia tak lepas dia punya bias voltage, dia tak akan boleh function dah. Dia tak boleh activate. At which point one of the transistor will enter cut off. So bila one transistor enter cut off, the other one akan stop. Okay, which then halts the base current of the next transistor, and that will actually put both transistor in the off state as each one was before any voltage again applied to it. Yeah. Okay, so here voltage versus current. Kita tengok macam mana that I have explained to you. Actually, now we are going to see what happened here. Okay, the first one you can see figure A. We observe that the circuit as the DC voltage battery is set to 0 voltage, and then a B, okay, this actually increase the DC voltage, yeah. Current through the circuit is at or nearly 0 here, belum lagi naik, as the breakdown limits has not been reached for either transistor. Okay, ingat dia kena sampai threshold voltage yang di-apply, baru dia akan activate, yeah. So in C, diagram C, when the voltage breakdown limit of one transistor is reached, yeah, it will begin to conduct collector current. Ingat macam mana transistor, kita ingat balik your normal transistor yang you belajar sebelum ni, ya. It will begin to conduct collector current, okay, even though no base current has gone through it yet. Normally, ingat dia punya collector ni, collector sini bersambung dengan base atas. Collector atas bersambung dengan base bawah. Itu bagaimana ia activate the base punya current flow. Okay? So, even though, yeah, it will begin actually to conduct collector current, even though no base current has gone through it. So what happened? This sort of treatment normally will actually suitable for PNP junction comprised of this Shockley diode, which are designed similar to a Zener diode. You ingat tak Zener diode? Dia boleh tahan reverse breakdown. Yeah? Dia bukan the normal diode. Yeah? This is the Zener diode. Because it is built to handle reverse breakdown. Ingat tak? Okay, without sustaining damage. Okay, where we assume that the lower transistor breaks down first. Okay, ini akan break down first, lepas tu sending current through the base of the upper transistor, and how that begins the activation of Shockley diode. Okay, that's how the arrangement of the Shockley diode. Okay, here, okay, kita tengok di sini, sini dia ada tunjuk current flow tu. Okay, so the upper transistor yang atas ni, the upper transistor, sorry lah, dia mula-mula ni banyak sikit teori sebab nak bagi explain kan current flow dan sebagainya ya. So kena fokus sikit dulu students ya. So the upper transistor receives the base current, okay, the upper transistor receives the base current and turns on, okay, dia mula activate and then it allow the lower transistor to conduct normally. Okay, the two transistors sealing themselves, okay, to the on stage, and after that both transistors are fully conducting. So here kita tengok dekat sini, when one transistor breakdowns, okay, what happened? Okay, when one, ini kita dah tahu kan macam mana dia dapat daripada kosong dan dia naik, okay, so that happens here. So kita nak tengok bagaimana it perform here ya. So when one transistor breakdowns, what happened? It allow the current, yeah, it allows the current through the device structure that acted as the output signal, yeah, of the device. So once an output current is established, okay, once output current to establish, it works to hold both transistor, okay, sebab dia dah activatekan yang bawah, kemudian yang atas tu activate. So it works to hold both transistor in saturation, okay, so which ensure the continuation of a substantial output current known as the output current feedback positively to the input, which is the base dia, ya, sebab base ni akan activate emitter collector dan ini akan activate base atas, okay, in the on stage, which is reinforcing ataupun regenerating themselves. So with both transistor maintained in a state of saturation with the presence of sufficient base current, okay, each will continue to conduct even though, okay, if the applied voltage is reduced to 0, okay, to the breakdown level. So the effect of the positive feedback is to keep actually both transistor in a state of saturation despite the loss of the input stimulus. So the original, okay, so secara dasarnya high voltage needed to break down one transistor and cause a base current through the other transistor. Mula-mula. Tapi bila dua-dua transistor dah activate and dia dah regenerate themselves, okay, even though kita reducekan the input voltage, they will still not off until in a very low one, okay, baru dia akan stop conducting. Okay, this is how it happens. As one transistor pass less and less collector current, okay, bila kita dah reduce, okay, it reduce the base current of the other transistor, which reduce the base current of the first transistor. So this cycle will continue until both transistor masuk dalam kawasan cut off. Okay, so when that happen, so based on the positive feedback, okay, the cause effect cycle between both transistor is actually to decrease in current through one works, which decrease the currents through the other. Satu berkurang dan satu lagi akan berkurangan juga, ya. Okay, and further decrease the current through the first transistor that indicates a positive relationship between output, okay, and inputs. So the results, okay, ini yang dinamakan hysteretic curve, okay. So the results curve, okay, on the graph that here is known as hysteretic curve, where as the input signal voltage is increased and decreased, the output current does not follow the same pattern or the same path, okay, going down as it did going up. Maknanya once dia dah sini, dia dah activate, dia akan cycle through this pattern until we really reduce the input voltage, only then it will deactivate. Okay, so saya recap sebab it's a long theoretical explanation. Okay, Shockley diode is a 4-layer PNP semiconductor device. It's actually a pair of interconnected PNP and NPN transistor. Dia macam satu PNP, kita gabungkan dengan NPN, di mana P atas dan N bawah, dan dua tu kita integratekan, kita embed, ya. So Shockley diodes tend to stay on, maknanya stay on, activate, on. Okay, I put it capital here, on, so that on. Once turn on, once it is latched, and stay off once turn off. How it is being turned off is actually to reduce the input voltage. Okay, so latch a Shockley diode. Okay, what does it mean? Once we exceed the anode cathode breakdown voltage, yeah, or exceed the anode to cathode critical range of voltage, right? That depends on the type of transistor. Either it's silicon or germanium, yeah. That is the threshold voltage for it to start activate. Okay. To cause a Shockley diode to stop conducting, what we need to do is we reduce the current going through it to a level below its low current dropout voltage. Okay, so these are the 4 things that you need to understand about Shockley diode. Okay, that's the first one. Okay, let's look at the second one, which is thyristor. Okay, so what is it actually? Thyristor. 1 minute, yeah. Okay, thyristor, okay, is actually in a class of semiconductor components as well. Also exhibit hysteresis, yeah, that property whereby a system fails to return to its original state after some cause of state change has been removed. Okay, so example of hysteresis is actually the mechanical action of a toggle switch. When the level is pushed, okay, toggle switch kan bila kita tekan dia punya push tu, it flips to one of 2 extreme states, okay, positions, and will remain there even after the source of motion is removed, which means after we remove our hand from the lever, kan kita tekan, kita remove, dia stay kat situ. So to illustrate the absence of hysteresis, yeah, consider the action of a momentary push button punya action switch, yeah, which returns to its original state after the push button is no longer pressed. So when the stimulus is removed, when we remove our hand, the system immediately and fully returns to its prior state with no latching behavior. Okay, so bipolar junction field effect and insulated gate field effect transistor are all non-hysteric devices. So they actually this actually do not inherent latch effect into a state after being stimulated by a voltage or current signal. So for any given input signal at any given time, a transistor will exhibit a predictable output response as defined by its characteristic curve. Okay, that is actually for the hysteresis earlier, yeah. So thyristor, on the other hand, are semiconductor devices that tend to stay on once it is on and tend to stay off once turned off. Okay, so a momentary event is able to flip these devices into either they are on or off states where they will remain that way on their own, even after the cause of the state change has been taken away. So these are useful actually as on-off switch device like a toggle, which toggle switch, and not to be used as an analog signal amplifier. Okay, Thyristor are constructed using the same technology as BJT, bipolar junction transistor, remember? Okay, and how then can a hysteric device, a thyristor, be made from non-hysteric devices, which is transistor? So this is actually the utilization of positive feedback. Also, sometimes we call it as a regenerative feedback. Well, what is feedback? Feedback is the condition where a percentage of the output signal, remember in our op-amp, we feedback the output to the input terminal, yeah? So here, feedback is actually the condition where a percentage of the output signal is fed back to the input of the amplifying device. Negative or degenerative feedback results will result diminishing of voltage gain with increase in stability, linearity, and bandwidth. So positive feedback, on the other hand, normally results in a kind of instability. That's why op-amp normally we will use negative feedback, where the amplifier's output tends to saturate. Okay, so in this case of thyristor, this saturating tends to equate to the device wanting to stay on once turn on and once off, and off once turn off, once it is off. Okay, so let's look at thyristor here. So this is actually the figure of your how it looks like. Okay, and this is the arrangement of thyristor with where it has anode, cathode, and another one is the gate. Yeah, so it can be considered as 4 layers of differently doped silicon rather than the 3 layers like our bipolar BJT. Okay, where actually for BJT, okay, for the normal bipolar transistor, we either have PNP or NPN. Okay, with the electrodes, I think everybody knows the 3 things. Okay, we have discussed earlier: collector, base, and emitter. Okay, the thyristor has a PNPN structure with the extreme outer layers referred as the anode, which is the N-type, and the cathode. Okay, and it has another one at the P, which is the gate. Okay, so the control terminal of this thyristor, okay, is the gate, and this is actually need to be connected to the gate is actually to the P-type layer that actually connects the cathode. Yeah. Okay, so let's see where is thyristor being utilized. Okay, these are some example of application of thyristor. Okay, for lighting, motors, involving AC power control, electronic switching. Okay, for why is it joined? Everything is joined. 1 minute. Here. Okay. Over voltage protection for power supplies. Okay. For phase angle triggered controllers as control elements. Yeah. Also for flash lamp. Okay. And flashlight where we normally need a certain cut off timing. Yeah. And also for high voltages that can actually handle reverse voltages. Okay, that actually makes them suitable for switching application, especially for AC category. Yeah, AC circuit. Okay, so I think this one we have discussed earlier. Yeah. Wait 1 minute. Why is it not here? Yeah. Okay. After this. So here, okay, this is actually the thyristor symbols and basic. Yeah, the thyristor, as mentioned earlier, is a semiconductor device that has a unique characteristic, which it has 3 terminals. Okay, this is the schematic symbol, which is anode, cathode, and the gate that controls. Yeah, as mentioned earlier, the gate is actually to control the terminal, while the main current flows is between the anode and cathode. Yeah, so from this circuit symbol, okay, you can see that it is actually a one-way device, giving rise to the silicon control rectifier. Therefore, when the device is used in the AC scenario, it will conduct for a maximum of half cycle. Yeah. In operation, the thyristor or SCR will not conduct initially. It requires a certain level of current to flow or to fire the gate, to activate this gate. Because once this gate activate, only then this thyristor will function. Okay, so once fired, the thyristor will remain in conduct, will remain active until the voltage across the anode cathode is removed. So the next half cycle will actually be blocked as a result of the rectifier action. It will then require current in the gate to fire, okay, to activate the SCR again, the thyristor again. In this way, the thyristor can be used as electronic switch. Yeah, here. Okay, let's look here. Okay, we have seen the symbol, and the next one we are going to see the structure and fabrication of our thyristor, which comprise of 4 layers, which is P and PN. Okay, and remember, this is the junction between the P and the N. Okay, remember, junction 1 is the one the most nearest to anode. Yeah, so again, the thyristor consists of a 4-layer P and PN structure with the outer layers. Okay, the extreme are referred to as the anode, which is the P, and the extreme here is the cathode. Yeah, so the control terminal of the thyristor is the gate. Okay, and it is connected to the second P located to the cathode. Yeah, so the thyristor has 3 junctions: junction 1, junction 2, junction 3. Junction is actually between P and N. Okay, the first junction, second and third. Okay, within these 2 transistors. So the 3 junctions are normally named as J1, J2, and J3. Yeah, serially with J1 is the one nearest to the anode. Okay, let's look here. How is it the structure and the fabrication of our thyristor? So what we need to do is actually we need to know how can we the level of doping, yeah, between these thyristor layers. Yeah, so the cathode is the most heavily doped, yeah, followed by the gate and the anode. Okay, so the lowest doping level is between the N here. Okay, which is the junction 3. Okay, and remember the gate is at here, and here is the anode. So thinner layers would mean that the device will break down at lower voltage. Okay, so in view of this thyristor semiconductor structure, the very high currents and power levels that some thyristor are used to switch, so the thermal consideration are very important. Okay, so the anode of the thyristor will control the rectifier, which actually usually bonded to the package, since the gate terminal is near the cathode. Okay, gate is near the cathode. Yeah, okay, and it needs to be connected separately. Okay, because it has 3. Remember, we have anode, gate, and the cathode. Yeah, so this, how do we actually accomplish this? the heat is removed from the silicon to the package, and a part of that, the external heat sinking. Consideration for the thyristor must be carefully implemented, otherwise the device may overheat and fail. Yeah, so that's what happened during fabrication. Okay, so the next one, why am I okay? It's okay. Next one is, how does a thyristor work? How does it function? Yeah, so we have seen the schematic diagram. We have seen this. We have seen how the fabrication of it. Now we want to understand, okay, how does our thyristor function? Okay, so the way in which a thyristor operates is different as compared to other devices. Normally, no current flow across this device. However, if a supply is connected across the device, yeah, which is the gate, okay, a small amount of current is injected into the gate, yeah, okay, then the device will fire and conduct. Okay. It will remain in the conducting state until the supply is removed. Okay, so the thyristor circuit can be considered as a back-to-back transistor. Here, this is one transistor one, this is transistor two. Okay, and the first transistor, remember what is the difference between this one and the one we saw earlier, the Shockley diode? Is actually it doesn't have a gate, and it needs to be the input voltage needs to be reduced very low for it to stop that hysteresis cycle. Okay, as for thyristor, we have gate here to ensure it can be off. Okay, so the thyristor circuit, we can consider it as a two back-to-back transistor here. So the first transistor, the first transistor is always at the anode. Yeah, we cannot switch which is transistor 1 and transistor 2. Transistor 1 is always at the one near anode. Remember, J1 is the one near anode as well. Okay, so the thyristor circuit can be considered as a two back-to-back transistor. The first transistor, yeah, with its emitter, here is the emitter, connected to the cathode, the emitter connected to the cathode of the thyristor of the NPN. This is PNP, this is NPN, yeah. Whereas a second transistor, the emitter, yeah, is connected to the anode of the whole thyristor. Okay, so here, the gate is connected to the base, okay, of the NPN transistor, which the function is actually to activate this thyristor. So when a voltage is applied across the thyristor, which is through the gate, okay, no current flow until, okay, no current flows because neither transistor is conducting. Remember, it needs to reach certain threshold level, yeah. However, if a voltage is applied to the gate, okay, once a voltage is applied to the gate, okay, and it meets the threshold voltage, okay, that will then cause current to flow in the base. Okay, remember here the gate is connected to the base. Okay, this will cause the current to flow in the base, and this will cause TR2 to turn on. Once TR2 is on, okay, this will pulls down the base of TR1. Remember, TR1 is up here, the base is connected to the collector of TR2. It will then cause TR1 to turn on accordingly, and in turn, this pushes current through the base of TR2, okay, meaning that the device will remain in the on state even if the gate voltage is removed. Okay, before it stops conducting. Okay, that is how our thyristor works. Yeah. Okay, so thyristor operation, the basic things that we need to actually recap or understand. One, the reverse blocking. Okay, it has three states. Reverse blocking is when this occurs, okay, when the current in the same way as that of reverse bias diode. So the thyristor can only conduct in one direction and blocks the other. What about forward blocking? This mode is where the thyristor operation is such that it blocks forward current conduction. Okay, that is normally carried out during forward bias diode. This will actually is not intends to turn on state as the gate has not been fired. Forward conducting in this mode, okay, the thyristor has been triggered into conduction by a current on the gate. Remember, thyristor, we need to activate the gate. Okay, current only needs to be applied to the gate to actually fire the thyristor, and after that it will remain conducting. Okay, so this is actually how and the basic operation of our thyristor. Yeah. Wait. I think we are missing something here. Because it's straight away triac, or we don't have the, okay, yeah, correct, triac. Okay, the next one that we are going to see is triac, yeah. So remember, we have seen Shockley diode, we have seen Shockley diode, thyristor. So the next one is triac. Okay, before we go to triac, any questions from you? Because this is the last one. After that, I think we have triac and then we have diac. I'll stop my slides for a while, just in case if you have anything that you would like to inquire. Students, I'll just check the chat box. So far, so good, everyone. Yes. Okay. In that case, maybe you want to ask me later, and we will proceed. Where is my slide? I think this one. Okay, I will just recall back here. Okay, this is the Shockley diode. Okay, remember the schematic diagram and the symbol. This is the diagram where it is actually two transistors connected back to back, but there is no gate. Yeah, this is the physical. It has anode and cathode, but it doesn't have a gate. Okay, so it will be activated once the base of the transistor activates, then only it will activate the above transistor. Okay, that is the Shockley diode. And in terms of voltages, how this is being actually illustrated is of the applied voltage, and it will continue this pattern here, okay, until the input voltage is being reduced to a certain level. Only it will fall into the cutoff and it stops. Yeah, this is known as the hysteretic cycle pattern of your Shockley diode. Okay. this is thyristor. Okay, it is actually a 2 transistor connected back to back as well, only that it has a gap, okay, that can control, that is being fired to activate your thyristor. Okay, this is actually the schematic symbol. It has a junction as well. Remember, the first junction is actually the one nearest to anode, and the gate is actually the P, yeah, the P type, and the last one cathode, yeah. Okay, this is how the circuit configuration of your thyristor. It has anode and cathode and the gate. Okay, and what happened there? It will continue to conduct where once the gate is activated, the gate is supplied with a voltage and it reached the threshold, it will activate the base. Once the base of transistor 2 is activated, okay, the collector will activate the base of the first transistor, and that happened. Okay, and it stops once the voltage at the gate is removed. Okay. Okay, let's see the third one, which is triac. Okay, so what is triac is all about? Okay. Okay, triac is one of the components which is also widely used in AC power control application. Okay, that can be actually used as a light dimmer for domestic lighting and many other controls. Yeah. So triac is actually a development of the thyristor. While the thyristor can only control current over 1/2 of the cycle, triac can control actually over 2/2 of an AC waveform. Okay, so as such, the triac, okay, as such, triac can be considered as a pair of parallel but opposite thyristor. Dia macam 2 thyristor yang disambungkan tapi opposite, ya, with 2 gates, ya, connected together, and the anode of one device connected to the cathode of the other. Okay, we will see later on here. Okay. Okay. So the fact that the triac switching action occurs on both half, which means the first half and the second half, yeah, of the AC waveform, that means the AC electronic switching application, the complete cycle that can be used later as a positive, because this is AC, yeah. So for basic thyristor circuit, actually what happened, only half of the waveform is used, and that means the basic circuit using thyristor will not utilize both AC, which is the AC cycle. So 2 devices like what has been built and known as triac, yeah, is required for both AC. However, a triac only requires 1 device to control half of the AC waveform, and in many applications is one of the suitable solution for electronic switch when it comes to AC. Yeah. This is where we see here. Remember our thyristor, how is it look like? Okay, this is our thyristor. Okay, here, remember, I just take the circuit here. Okay, and we go to our I put it here. Okay, I reduce it. Okay, this is our thyristor, this is our triac. How it is being connected, okay, for it to handle AC waveform, or else it is just one way. Okay, it's meant for half cycle only. So the triac, like other electronic components, okay, the triac actually has its own circuit symbol here. This is its circuit symbol. Okay, and for use on circuit diagrams, and this indicates the bidirectional properties. So the triac symbol can be seen to be a couple of thyristor. Ada dua thyristor sini yang dia connect opposite ya sini. That is being merged together. So like thyristor, a triac has 3 terminal as well. Yeah. However, the names of these are a little more, difficult to given because the main current that carries the terminal are connected to what is being effective to cathode of one thyristor and the anode of another within the overall device. Kita tengok macam mana dia berfungsi di sini ya. Gate sini, gate dia dengan gate dia dicommonkan, okay, is being common. And then this one is the anode MT1, this is the anode MT2. Okay, so there is a gate which acts as a trigger for triac, yeah, here, okay. That is actually the purpose is to turn on the device, okay. So in addition to this, the other terminals are both called anode. Dia ada anode 2 dan anode 1, yeah, here. Main terminal, MT ni main terminal 1, main terminal 2, which is anode 1 and anode 2. Okay, so when we use triacs, okay, both MT1 and MT2 will have very similar property. So we see here, the triac is actually a pair of parallel but opposite thyristor. Ingat ini thyristor kita asalnya. Ini adalah dua thyristor connected begini dan dikenali sebagai triac, ya, known as triac, ya. So with the 2 gates connected together here, okay, and the anode of one device connected to the cathode of another. So what we have is actually anode 1 and anode 2. Okay, so triac switching action will cause both positive and negative cycle kat sini. Okay, so for basic thyristor, kita tahu dia akan hanya bagi sebelah saja. So triac yang sesuai untuk digunakan when it comes to AC circuit, okay, because it can handle both positive and negative, and that is why it is one of the suitable to be used as switch when it comes to AC. Okay, we will see here. This is still triac, yeah. Okay, di mana it is bidirectional property. Okay, dikapulkan begini opposite. Okay, it also has 3 terminals macam thyristor. Okay, cuma thyristor, remember dia ada apa? Dia ada anode, gate and cathode. Okay, whereas triac, both gates common as one gate and not connected to the cathode of the second thyristor and the other one. So it has a main terminal 1 as anode 1 and main terminal 2 as anode 2. Okay, that handles the positive and negative of the AC waveform. Okay, so that's the triac symbol. Next, we will see how does a triac work. Okay, bagaimana ia berfungsi. Okay, so for the operation of the triac, okay, we can imagine that the circuit symbol that the triac consists is actually 2 thyristor. Ya, sini 1 thyristor, ini 2nd thyristor in parallel but opposite direction, different way. Okay, so the operation of the triac kita can imagine or kita can actually visualize. Although the actual operation at the semiconductor level is rather, yalah, kalau fabrication dia macam susah kita nak bayangkan lah sebab it is being fabricated, but we will try here, ya. So the triac structure adalah begini. Okay, this is the basic structure of our triac, ya. It can be seen that there are several areas of N-type, NP-type material. Sebab setiap NP kena ada N and then kena ada P. Okay? Dia kena NPN. Kalau tak nanti you faham lah kan? Dia kena couplekan begitu. Okay? So the triac, this is when it comes to basic structure during fabrication, yeah. So the triac structure is shown below here, and it can be seen that several areas of N-type and P-type material that form what is effectively a pair of back-to-back thyristor. Okay, NPN. Okay, and then kita pun ada NPN. Begini, ya. So the triac is able to conduct in a number of ways, more than the thyristor, ya. So it can conduct current irrespective of voltage polarity of terminal MT1 and MT2. It can also trigger by either positive or negative gate current. Dia boleh function positive or negative because of the nature of the configuration of this triac, yeah, the way it is being connected, irrespective of the polarity of MT2 as well. So this means dia ada 4 trigger modes triac ni, okay, ataupun 4 quadrants yang kita akan tengok kemudian dekat sini. Ya, tapi kita tengok ni dulu. Okay, so the first one is actually mode for the MT2, which is current is positive, gate current positive. Okay, and then kalau I negative, MT2 current positive, gate current negative. Okay, for the third one, which is the third quadrant, MT2 current negative, gate current is positive, and MT2 current negative, gate current is negative. Okay, ada kat sana. Kat sini sorry. I tak tunjuk pula kat sini. Okay, so it is also found that the triac trigger, okay, the triac trigger current is sensitivity is greatest when the MT2 current, kita tengok mana MT2 current sini, MT2 current and gate currents are both the same polarity. Maknanya kalau MT2 positif dan gate current juga positif, maknanya gate current positif dulu dan MT2 juga positif, ya. So itu adalah yang dia punya highest ataupun greatest, ataupun bila dua-dua negatif, MT2 current negatif and gate current is negative as well. Okay, so ini adalah quadrant 1, okay, and quadrant 3. Kita tengok kat sini, ya. Sebab bila di sini, ya, dua-dua ni, okay, V dan I-nya dua-dua positif di sini, ya, what happen? Dia akan as such, and then bila dia reach dia punya reverse di sini, okay, dia akan dapat di sini. Okay, so this is actually during negative and negative. Okay, so the greatest value is when MT2 and the gate are both in the same polarity, either both positive or both negative. Okay, if the gate and MT2 currents are of the opposite, maknanya jika salah satu positif ataupun negatif seperti dekat sini, positif negatif, MT2 current positif, gate current negatif, ataupun MT2 current negatif, gate current positif, what happened actually? The sensitivity is about how the value when they are in the same polarity. Okay, kalau opposite maknanya dekat sini, ya. Satu I positif, okay, current voltage negatif. Okay. Dan juga di sini. Quadrant 2 dan quadrant 4. So the best is actually quadrant 1 and quadrant 3 that actually perform the triac punya function. So again here, okay, I have actually explained this, how does a triac work here. Okay, and we will see application of triac. Okay, triacs juga digunakan dalam banyak application, which is macam saya inform tadi, for a low to medium power switching requirement, yeah, where large level of power needs to be switched. 2 thyristor ataupun tend to be used as they can be controlled more easily, yeah. So untuk lighting control, untuk fan and motors, small motors, electronic switch as well, and in one specific application, triacs can actually be included in modules called solid state relay. Yeah, So here, what happened is actually the optical version of this semiconductor device is activated by an LED light source, turning the solid state relay on according to the input signal. So typical within this solid state relay, the LED light or infrared source and the optical triac are contained within the same package. So sufficient isolation will provide to withstand high voltage, which may extend to hundreds of volts for possible even more. That depends on our design actually. So solid state relays come in many forms, but those used for AC switching may also use or opt for triac. Okay, so that is actually triac application. So let's see now using triac. So there are a number of points to note, when we use triac, the things that you need to actually what shall I say, not to say take care, but to consider and to look into. Although this semiconductor device operate very well, this triac, to get the best performance out of them, it is necessary to understand a few hints on tips on using triac. So in nature, okay, it is found that because of their internal construction, this triac, and the slight difference between the two half, kalau you nampak kat sini, nampak tak tadi kan, dia macam ada, bila dia nak bertukar dari positif ke negatif, dia tak smooth begitu, okay, dan vice versa bila negatif nak ke positif, so the slight differences between the two halves, which is the positive and negative. So these electronic components do not fire symmetrically, so this result in harmonics. Siapa tahu pasal AC dan juga ni selalu akan ada harmonics distortion yang masih menjadi one of the main research agenda when it comes to AC. Okay, harmonics being generated, so the less symmetrical the triac fires, the greater the level of harmonics that will be produced. Okay, ini you kena ingatlah kan, dia akan lead to harmonics. When it is AC, we cannot run from harmonics. We can never get a perfect, zero harmonics. There will be some harmonics there. Okay, so it is not normally desired to have high levels of harmonics in a power system, and as a result, sometimes triacs are not a favor, okay, for high power system. So instead, for this system, 2 thyristor may be used. Instead of pakai triac, dia pakai 2 thyristor, lagi better, kalau at certain high power, because sometimes it is easier to control firing of 2 different thyristor instead of 1 triac, because the gate are being common. So to help in overcoming the problem of the triac because of the non-symmetrical firing tadi, yang tadi tu, sebab dia fire tadi dia tak dapat yang smooth tu kan. Okay, the results of harmonics, another semiconductor yang kita akan tengok lepas ni adalah diode AC switch, okay, which is open place ataupun which is open use in series with the gate of the triac. Okay, so the inclusion of this semiconductor device normally will help the switching more even for both triacs, which means for both halves of the cycle, and thereby it actually will create a more effective electronic switching. Okay, so the results from the fact that the diac switching characteristic is, which we will see after this, is diac. Kita dah tengok Shockley diode, kita dah tengok thyristor, kita dah tengok triacs. Triacs ni kalau high power dia akan generate harmonics lah, which we don't want actually, So kita akan tengok lepas ni diac, So the results from the fact that the diac switching characteristic is far more even than that of the triac, okay? So since the diode prevents, what we will see after this, how the diode actually prevents any gate current flowing until the trigger voltage has reached a certain voltage in their either direction, which makes the firing point of the triac more even in both direction. Okay, so lepas ni ini triac circuit example. Ini bagaimana kita guna triac sebagai some example of, wait, oh, this is triac. No, here, triac, sorry. So this is one example of triac here. The triac can actually, there are many ways actually triacs can be used, yeah. The two example that I'm sharing with you now, okay, give some idea of what can be done with this device of triac. So one is a simple triac electronic switch circuit here. What happened here is actually the triac can function as an electronic switch, which could enable a trigger pulse here, yeah, of a lower power switch to turn the triac on. Okay, it will turn the triac on to control a much higher level power levels that might be possible with a simple switch. Okay, this is one example. Yang ini adalah actually a basic triac circuit untuk control dissipated power in the load. Yeah, that is one example. Triac variable power or dimmer circuit, untuk sebagai dimmer circuit, di mana a basic triac circuit using phase of input voltage, sorry, input waveform to control the dissipated power in the load. So that there are actually many more triac circuits that can be used, because this device, besides, you know, it causes harmonics in high power, it is actually quite versatile and can be used in a variety of circuits where low to medium, typically to provide various forms of AC switching. Yeah, as long as the harmonics is tolerable and within your design and requirement, you can actually consider for triac. Okay. Okay, so before we go to diac, triac, remember we have seen Shockley diode, we have seen Shockley diode, thyristor, and we are now in triac. Yeah. Okay, when used, ini kita recap balik ya, sebab kita tak boleh nak recap next week. Ni last class kita. So lepas saya ajar, saya recap terus ya. So a triac acts like a two thyristor which is connected back to back. Nampak di sini ya, di triac kita ya. So bila kita use to control AC power to the load, triacs are often accompanied by diacs, which we are going to look after this. Okay, in series with their gate terminals. Why? Because the diacs will help the triac to fire more better, consistent lah from one polar to another. So triac ni, remember dia ada main terminal 1, main terminal 2, okay, and the gate is actually combined together to produce one gate as the triac di sini. Sini ya, gate dia sini. So for us to be able to trigger a triac, okay, mula-mula kita kena trigger dia punya gate current, ya, which must come from the main terminal 2, ya, main terminal 2 ni dulu, baru dia akan activate main terminal 1. That will actually handle the both half of AC waveform, ya. Okay, so now we are going to see what is diac. Kita tengok sikit lagi. What is diag? 1 minute ya dia. Okay. 1 minute ya. Saya okay dia dah turun. So betul tak suruh dia naik. Okay, what is a diag? Okay. So a diag is actually this is diag. Yeah, diag symbol. Okay. This is the circuit diag symbol. A diag is actually a bidirectional semiconductor switch, which actually we can turn it on both forward and reverse polarity once it exceed a certain level. Yeah. So dia ni adalah a better version of triac. Yeah. So a diag is actually a full wave or bidirectional semiconductor, which can actually turn on in both forward and reverse polarity. So the name of the diag comes from the word diode AC switch. Kita tengok kat sini. Diag. I merahkan dia. Okay, that's where the name diag came from. Okay, diode AC switch. Okay, so this is the diag symbol. Okay, the names come from the word diode AC switch. The diag is actually an electronic component, yeah, that is widely used to assist even to trigger a triac when used in AC switches. Yeah, so and as a result, okay, they are often found in light dimmers. Okay, bila kita nak untuk control lighting, such as those used in domestic lighting. Yeah, so these electronic components are also widely used in starter circuits. For our lampu tu, apa tu, fluorescent lamp, yeah. So although the term is not often seen, yeah, diag may also be called symmetrical trigger diodes. Okay, sebenarnya a term that results from the symmetry of their characteristic. We will see the characteristic after this. Okay, so diag comes in a variety of format. Okay, as discrete components, they may be contained in small leaded packages. Yeah, they can be obtained in surface mount packages juga, in large packages that bolt to a chassis, atau a variety of other packages. Dia ada pelbagai lah mengikut kegunaannya. As they often use as a diag triac combination, dia kadang-kadang dia ada itulah sebenarnya to actually handles the triac. They are often integrated into the same die as a triac juga kadang-kadang, ya, but it contains triac di situ. Okay, so this is the symbol. This is the symbol of our diag. Sorry, of our diag. Yeah. So the diag symbol used to depict the electronic components, okay, can be considered as a combination of what appear to be two diodes connected begitu, ya, opposite direction. Owing to the fact that diags are bidirectional devices, the terminals cannot be labeled as anode, okay, and cathode as they are for a diode, okay. So instead, they may be labeled as A1 and A2 juga, which is main terminal 1 and main terminal 2, okay. And let's see the operation of our diag. Nampak tak smoothnya di situ as compared to triac tadi, ya. So diag circuit use the fact that a diag conducts current only after a certain breakdown voltage is exceeded. Okay, so the actual breakdown voltage that depends actually upon the specification of the particular component type. Again, it is the V threshold tu lah. Ya, sama the type of kita punya material tu, ya, is the germanium or silicon. That's the most popular one. So when the diag breakdown voltage happens, yeah, the resistance of the component will decrease and abrupt, and this lead to a sharp decrease kat sini in the voltage drop across the diode and a corresponding increase in current. Okay, and it was up there. So the diode will remain in its conducting stage until the current flow through it drops below a particular value known as the holding current. And when the current falls below the holding current, the diode switches back to its high resistance or non-conducting. So diodes are widely used in AC application, and it is actually found that the device is reset to its non-conducting state each time the voltage on the cycle falls, so that the current falls below the punya holding current. So as the behavior of the device is approximately equal in both directions here, okay, it can actually provide a method of providing equal switching for both half of the AC cycle, okay, and most diodes actually have a breakdown voltage of around 30 volts, okay. That is some general info for you. Although the exact specification normally that depends on the particular type of device. Okay, one interesting thing that you need to understand is the behavior is somewhat similar to that of a neon lamp, although they offer a far more precise switch on voltage. They provide a far better degree of switching equalization. Yeah. Okay, so ini adalah diode operation. Seterusnya kita akan tengok diode structure. Yes, please bear with me. Okay, this week memang teori banyak. I understand that. Jangan tidur ya. Because to make you understand the concept, yeah. So diode. So diode here. This is how the diode can be fabricated, yeah, as either a 2-layer or a 5-layer. Dia ada dua cara macam mana kita boleh fabricate. So in the 3-layer structure, the switching occurs when the junction that is reverse bias experiences the reverse breakdown. Okay, dia banyak based on reverse breakdown. Okay, so the 3-layer version here, this is the 3-layer version. The 3-layer version of the device selalunya inilah yang the common one, yeah, the common one. Okay, where it can have a breakable voltage of around 30 volts, but sometimes kita ada juga yang 5-layer punya ni. So that's the structure of our diode, yeah. So this is how it is being fabricated. And for most application, a 3-layer version of a diode is sufficient, yeah, untuk switching characteristic. But there are times that they will use the 5-layer version for certain application, for some application. Okay. So diode application here. So this is the diode triode combination. Okay, so one major use of diodes with the triode circuit, because why? Kita dah tengok tadi triode dia ada problem dengan firing symmetrically kan. So that's how we put the diode into it. Okay, dekat sini ya, dekat dia punya gate tu. So the non-symmetrical firing, okay, will result and give rise to the unwanted harmonics, and it can actually reduce. It is not setting the harmonics to 0, but it can reduce the harmonic effect. Yeah. Okay, which means the waveform, the less symmetrical the waveform. Okay, lagi kurang dia, lagi bagus dia punya symmetrical, so lagi kurang harmonics berlaku. So to reduce this. To solve this issue, or to reduce this issue, yeah, for the non-symmetrical operation because of the triode. Sini saya tunjuk triode yang tak symmetric tadi. Sini. This one, yeah, dia tak symmetric macam tu. So to reduce this, because that actually leads to harmonics, which is what we normally don't want harmonics to occur when it comes to AC, yeah. So sorry, dah sampai sini. Okay, to actually to resolve the issue that results for the non-symmetrical operation, a diode is actually placed in series with the gate. Di sini, seperti sini, yeah. So why? Because this device will help the switching more even smooth for both half of the cycle, which in accordingly will reduce the harmonic effect. So this results from the fact that the diode switching characteristic is better than our triode. So since the diode can actually prevent any current flowing until the trigger voltage has reached a certain voltage, okay? Okay, so this makes the firing point of our triode more even, much better in both directions, positive and negative. So in view of this usefulness of this combination, diode may often be built into the gate terminal of the triode. This is one method of how to reduce harmonics, okay, for us to have a smooth transition. So diode are a widely used electronic component. Okay, so the main application of diode is for use in conjunction with triode, as such as here, as we have seen here, to equalize their switching characteristic. So when we equalize the switching characteristic of these triodes, okay, the level of harmonics, okay, is actually a good topic for you to do your research here. This harmonics distortion is actually by equalizing the switching characteristic of these triodes, yeah, the level of harmonics generated when switching AC signal can be reduced, okay, can be lessened. So despite this, for large application, normally 2 thyristor are generally used, or you can use diode-triode combination, which is very useful for lower power applications, including light beamers or whatever application that I have actually mentioned to you earlier. Okay, I guess that's it, Prof. This one I just give them as an assignment for them to try out later. Okay, I guess that's it for this week, Prof.
Yeah, Prof. Yeah.
I will open for any question and answer from the students. Anything that you would like to ask?
Ada pertanyaan para mahasiswa sekalian, silahkan mau disampaikan.
Or else next week, no more next week.
Yeah.
I will pass the notes to your professor. Sorry, dah lupa sudah habis. I will pass the notes to your professor. Not to worry, you can have the notes later on.
Yeah.
And I will also pass the results of your quiz just now to your professor. And actually this week is much better because many of you managed to get a full marks. I will read the names here. The one that managed to get full marks, Matthias. Okay, very good. And we have with several I found just now. One minute. Yeah, Bayu Adi Pambuda, full marks. Dia Yunita Utari, full marks. And I saw one more just now. Christopher Nathaniel, full marks. And Raihan Zaki Rizqullah, full mark as well, 5 of you. And one more, Salsabila Fatiha Rahma, full mark. Okay, Aldo Luhong Baskoro. Okay, Ikmal Ramadan. Dalam 8 orang ni full marks. One more, Rifai Try Cahyoko. Minta maaf kalau saya sebut salah. Aditya Febrian. Salma Diamantiva, very good. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of you. Out of total students that attempt this quiz, 101. 10% full mark. Very good. Which means you understand the basic concept of what is low pass, high pass, and band pass. the basic things. Congratulations to all 11. Okay, any questions, everyone?
Silakan kalau ada pertanyaan.
This week is quite challenging because of the theory, but that's it. To understand the concept is very theoretical this week. I understand.
Oh yeah, thank you. Prof,
Yes.
for administration process, maybe I need cover of your passport.
Okay. I will pass to you.
Yeah.
I will pass to you.
And tax card, maybe like tax card in Indonesia and PWP. I don't know in Malaysia say about that, like tax card. Maybe I don't know in Malaysia what's name.
Number. Give the text number. Is it?
Yeah. Tax number.
Okay, I will give the text number.
Yeah.
I will capture.
Yeah, the card.
I don't have card, but statement.
Oh, okay. Yeah.
Statement, text statement. Maybe you can get the number from there.
Yeah, I need the number.
Okay, sure.
Silakan kalau ada pertanyaan. Terima kasih ya, Prof. Norita sudah memberikan banyak ini materi, terutama adaptasi in English. Your English is very fluent, so different with me, maybe with if I say in English.
Okay, so that's one question, Prof. Permission to ask. My question is how to model and simulate the interaction between thyristor and other electronics in complex electric power such as centralized grid or distribution grid. Okay, how to simulate? Yeah, I need to check what software that we have. 1 minute. Normally when we simulate, that depends on the software that we have. Sebentar ya, I cuba ni. I cuba recall apa software kita ada. In your university, what software do you have? If you can.
Sometimes we use Proteus. Yeah, but illegal software maybe we use because too expensive to the price.
The license.
Yeah.
Because if first we need to have the software, simulation software like MATLAB. Do you have MATLAB?
Yeah, MATLAB.
We can use MATLAB and Simulink or PSCAD. Those are the software that can actually simulate the behavior of whatever that we learn today. Where's that student? Does that answer your question? Oh, sorry, because he asked me personally. You don't mind I share the answer, yeah? I share to everyone. What is the simulation? Because when it comes to simulation, the first thing that we need to do, okay, everyone, we need to identify the system component. I think everyone knows. And then we need to have the model, okay? And then the arrangement, and then use that simulation software. So some of the simulation software that is suitable for this, whatever that we learn today, MATLAB, Simulink. I don't want to teach you, but you can have pirate MATLAB, okay? Okay. PSCAD, these are some of the software available, and start putting in the input so that you can see how the behavior of the components. Okay, does that answer my question, Alif Yandra? Alif, I hope that helps. So you need to know how you want to design the grid first, the centralized grids or the distributed grids, okay? And then these are some of the software that you can actually use. MATLAB is actually very good and very user friendly. I mean, it's high level. You know, the command is quite easy to understand, and they have many examples in their what shall I say, in the tools that we can see. Any more questions?
For triac and diet, cannot use MATLAB maybe.
Pardon? Pardon, Prof?
For triac and diet, we cannot use. It's not stable. For diet, cannot use MATLAB.
Okay, then Simulink. Try
Simulink.
Simulink. Because Simulink, it has the components that, you know, we arrange, yeah?
Yeah.
We run it. In our university also we have some, but the license is quite expensive, and you can only use it in the labs. So some of our students also, they have ways on how to use it outside the lab.
Okay.
Students are very creative. They find ways to study.
Yeah.
To survive and study.
Silakan kalau ada pertanyaan nih, masih ada waktu kira-kira 10 menit ya.
We have another 10 minutes.
Ini terima kasih, ini tadi pesertanya sempat mencapai 100 lebih ya.
Yeah, very good.
Iya, saya minggu lalu itu hanya kisaran 60, makanya saya minta mereka untuk lebih aktif untuk berpartisipasi.
Yeah, just to share knowledge, you know, things like that.
Yeah.
So that we can understand better. But I think your students understand OPM very good.
Yeah, thank you.
Which is good.
With good,
we are going to see OPM in digital circuit later on.
yeah. Maybe we use on next semester with system digital. Maybe.
Yes, yes.
Yeah.
Again, yeah. For the ADC, DAC.
Yeah.
And counters.
Yeah.
All those are OPMs.
Yeah. Silakan kalau ada pertanyaan.
When is their exam? Rob? When are the student exam?
About again, 2 weeks again maybe.
Oh, in 2 weeks time. Okay. All the best.
Yeah.
All the best, inshallah. Study smart. You need to study smart. How to study smart? Understand basic, grasp the concept, and try to do many questions. If you don't understand, ask. Because I don't know, my students, most of them, they don't like to ask questions.
Okay.
If you don't like,
And
if you prefer to ask your, if you don't prefer to ask your lecturers, ask the good students, your friends. But we need to communicate. You know, just study alone cannot, because we don't know what we understand, and we don't know whether we understand the correct things or not. Okay, so it's good to group study and discuss.
Yeah.
Okay.
Jadi Prof Norita itu sama dengan yang saya sarankan, mahasiswa itu harus belajar berkelompok, itu ya, berdiskusi. Karena kalau sendirian itu kalau nggak paham buntu, dia nggak paham, stuck gitu. Jadi ya ada teman diskusi. Nanti kalau salah ada yang mengingatkan, atau tidak bisa ada yang mencari jalan keluar gitu. Jadi kalau kita itu memang belajar elektronika itu kan butuhkan pemahaman, basic konsepnya itu harus paham, sehingga butuh teman diskusi, karena kalau pemahamannya salah itu ya mengerjakannya tidak bisa atau tidak gitu. Kira-kira yang terakhir disampaikan Prof. Norita. Okay, Prof. Maybe you will end the session. You can say the last speech for this season,
Okay.
please. Yeah.
Yeah, thank you again, Prof. First of all, I wish to thank UNNES for the opportunity for having me as this visiting lecture program. Okay, Alhamdulillah. Secondly, I wish to say all the best and good luck to all my students. Okay, my doa that everybody will pass with flying colors. Okay. Never give up when it comes to study, because we need to actually further ourselves to make us better, and it's never too late to understand prior to your examination, and never give up. Okay, because you people are very young and you have a long way to go, so never give up, and always put that that fighting spirit to be a better person every day, inshallah. If you have that, the rest I think you can meet and challenge and overcome, inshallah. Yeah. So bagaimana cara belajar, I think your professor have informed you that we need to learn. If you don't understand, communicate and talk to your lecturers or to your friends. Okay, all the best everyone. Mohon maaf kalau ada apa-apa salah, saya mohon maaf. Saya sentiasa cuba untuk buat yang terbaik. Segala yang baik datang daripada Allah. Okay, saya mohon maaf ya. And thank you again for having me. All the best. Thank you.
Thank you, Prof. As lecturer, this visiting lecturer, for the your time, your attention for this program. So maybe there is a mistake, please forgive us. Maybe I hope we can see on next semester.
Inshallah.
Yeah.
Inshallah.
So the collaboration ini dapat berlangsung terus. Begitu. Terima kasih. Kita tutup. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you everyone. Okay, take care.
I will end.
Sure. Okay.
Yeah.
Sure.